Okay, I have just started the recording and now I'm going to start the lecture. All right, so today we are going to study a new paragraph which is called feed forward feedback system. Feed forward feedback system. So what we saw last time is feedback systems whose transfer function was of the type 1/1 plus A1 Z inverse plus E2 Z to the minus 2 plus AN Z to the minus N. But the even more general system will have a transfer function that will also contain a polynomial at the numerator. So the general question is, how do we make this such a system? So most general transfer function is like that. Most general transfer function is of that type. And one wonders what system can have such a transfer function. Remember that the transfer function is the Z transform of the impulse response G of n. So one way to implement such a transfer function is to say we can always write G of Z as B of Z, or let's say G1 of Z times B of Z, where B of Z is the numerator and G1 of Z is the fraction. So, but if G of Z is of that form, then can somebody tell me what is going to be G of n given this? Okay, Jamel, you have your microphone on. Does it mean you want to answer? No? Okay. Jamel, you have your microphone on? All right. Okay.
No, it's not on.
But I saw a message. Somebody said maybe you wanted to say G1 of n convolve with B of n. Gregory wants to say something. So now suppose that we know how to implement. Suppose that we know how to implement the system, the LTI system. This designates the LTI system of impulse response G1 of n. And this one is the LTI system of impulse response B of n. So suppose that these systems are available or have been made, then how to make this one. Can somebody tell me? So Gregory has still his hand raised. So does it mean you want to answer? Anybody else wants to say how to? So suppose that this system have been made, how to make this system whose, I'm sorry, do you see my cursor when I do this? No, it's too small, right? Okay. Do you see my cursor when I do this? If you don't see it, make the screen full screen. Okay, I see answers, but yes, you see. All right. So I've seen some. Shahana, okay, you want to say something? All right. I have a question. When the student displays an answer by text, do you see it, all of you? Like Shahana just displayed in graphically the answer. Do you see that answer, or should I write it down? Okay, wait. Okay, it's yes, you see. So whenever you see all these yes, you see them, right? Okay. All right, so yes, that's the way to do. You cascade them, yes. For example, what order should I cascade them? This, okay, this way, or this way, or the other way? Should I cascade like that, or should I cascade the other way? The other way? That way? That way is fine? Does it matter? Does it matter? Yes, that's the right question. Does it matter? Does not matter. It does. No, wrong. It does not, because convolution is commutative. Okay, what's the opposite to bonus? Malus? Malus? No, I'm kidding. Don't worry. All right. So no, it doesn't matter, because you can use convolution is commutative. All right. Now, the question is how to make these systems. So this system has transfer function g1 of z. Do you know what system performs has this transfer function? So the answer to this was from last lecture. It is the nth order feedback system, which I show here. This function does have this type of transfer function. We saw it from section section 3. Okay, we saw that. Meanwhile, how to implement this? All right, so now the next question is how to implement this. Next question, how to implement this? Now, what the Z transform of this system is like that. So you know how to get B of N from this B of Z. You know that this is the value of B of 0. You know that. This is the value of B of 1. This is the value of B of N. And the other values are 0. So you're going to get a sequence like that. Where you get B sub 0, B sub 1, B sub N, and elsewhere you get zeros. All right. Now, how do you implement a system whose impulse response is like that? Okay, I'm waiting for your answers. It's the same. I don't know. I don't know what you mean, Shahana. It's the same. I want to see a system. You mean this is the same as the feedback system? Okay, I give you a hint. The error is in the material that is the material that is in that you have to prepare for the midterm exam. Impulse system. No, I didn't say impulse system. I said that this is, I want the LTI system of impulse response B of N like that. How do you implement this system? Yes, everybody sees that? FIR system. FIR system. So here's the FIR system. I'm going to copy it. You remember the FIR system that was asked during the virtual interview I was simulating? This system has impulse response. The sequence whose coefficients are the coefficients of the multipliers. All right, so then, therefore, to make this system, you need to cascade these two systems together. And the system is this one. The second system is the FIR system. So as a final result, you are going to get this global system that I'm going to show you. Here. Then this is going to be equivalent to, so this is the equivalent to this, which is equivalent to G of N. So here, impulse response G1 of N, impulse response V of N. This is the cascade of the two. So that has transfer function g of z equals, so now this is the complete transfer function. Oops, I made a mistake here. Wrong button. Sorry, there's a delay. Okay, let me save when there's too much delay. That means it might be about to crash. Okay, copy, then so the complete g of z is this. All right, so conclusion. One way to implement a system whose transfer function is like that is this implementation. All right. Now, the question is, the next step, question, what is G of n? So you want to perform an inverse Z transform of this fraction. And again, the answer is to perform a partial fraction expansion. But it's more complicated than what we saw last time, because the last time we didn't have any numerator, we only have a denominator, and it was a degree 2. All right, so let's go through the complete resolution of that inverse Z transform. So maybe you remember from Laplace transform that you had to consider two cases because you had to discuss something about the degrees. Do you remember? Somebody tell me what discussion we have to make first. Okay, somebody says something. No? You forgot your Laplace transform? N has to be greater than M. Yes, it doesn't have to, but this is a discussion. There are two cases, which I'm going to call super cases. We're going to assume that super case 1, we're going to assume, so I'm going to assume that M is less than N first, because this is the easy case. So in this case, you can apply partial fraction expansion, but first step, you need to factorize denominator of G of Z. But as we have seen it with the second order case, the factorization of the denominator is of the following form: 1 minus lambda 1 z inverse times 1 minus lambda 2 z inverse times. These times, one easily guess that you need to have n factors of that form. Where, again, lambda 1, lambda 2, lambda n are the solutions of a different. So again, you don't solve this equation because you have negative powers of z. You have to solve the version involving positive powers of z. So which you obtain by multiplying the whole thing by z to the power of capital N. All right, so obviously, I mean, I expect that you will be worried if I give you such a problem where n is larger than 2. So if n is equal to 3, typically, I will make sure that there is an obvious solution to this equation, like z equals 1 or z equals minus 1. And then you will be able to reduce the degree of the equation by factorizing that solution and reduce the equation to a second degree equation. Anyway, you don't have to worry about that. I will not give you difficult algebraic equations at an exam, because at an exam my goal is not to test you on your algebraic efficiency or ability, mainly to test you if you know how to use the right method. All right, so lambda 1 and lambda 2 are the poles of G of Z. All right, so that's step 1. But step 2 is to go ahead with the partial fraction expansion. All right, so like in the second degree case, there are several cases. Case 1, the friendly case when all the poles are distinct. So the partial fraction expansion implies that G of Z can be put in the form of a small sum of fractions of degree 1. This is the friendly case, I will say. So here, but how to find the coefficients A1 and AN? So there are two methods, as you know. Method for non-educated people. So you know what this is about, but just to review, basically you go backward, you go backward. Put the above expression of G of Z in a single fraction and find A1, AN by writing that this is equal to the first fraction, no, here, must be this. Be careful, this is Be careful, this is different from, this is not 1, all right? All right, so then you will end up with m equations. In fact, you end up with yeah, you'll end up with m equations, and or actually n equations, because you can always say this is a polynomial that goes all the way to n with 0 coefficients. Now you also have the method for educated people, and that you know what this is about. Method for educated people. So for each coefficient, you are going to have the same formula. And for each index from 1 to n. Same formula as in the second order case. Now, typical mistake. Students forget that Z has a numerator which is different from 1. So when after you have simplified this, students, they forget that when they plug in Z equals lambda I in the formula, they forget that there is something not different from 1 here. All right, so that's actually the friendly case. And once G of Z, the coefficients of this expansion are known, then by inverse transform, you know that G of n
There is no audio.
the audio has been muted. I don't know why. Can you tell me for how many seconds? 1 minute?
10 seconds.
Okay, thank you. I don't know what happened since. Yeah, it's really strange because my tablet is not the where I have my Blackboard window. All right, so G of n is down here in case 1. Case 2, that is the more difficult case. Assume that we have a double pole. But the other poles are distinct. So in this case, partial fraction expansion, you remember from Laplace transform that there's a special formula in this case. Be careful, Z transform will give you something different. The expansion, so you have to be careful because some students, they just apply Laplace transform formulas, but this is not right. So what you're going to have is something like that. Up to some modification. Which is like that. But so this may remind you of what you saw in Laplace, but you have to be careful about the exact formula. The problem is how to find A naught, B naught, A3, AN. So there are three methods. Again, method for non-educated people. Same principle. Go backwards. Now, second method for semi-educated people. So usually when I teach that in class, I would see students smiling or laughing. All right, so what this is about? It's an attempt to get explicit formulas for each of the coefficients. So what I'm going to do is I'm going to write attempts to, like, I'm going to guess some possible formulas, and then we're going to discuss with you if you feel that this is correct or not. So I believe that A naught would have an expression like that. I'm just trying to imitate the second order case. I would believe that something similar could be written about B naught, provided that you put a square. And all the other ones, I believe this formula should still work. But we're going to do that together. You're going to vote for each of them. Which one you think is correct. So we're going to do this through polling. So the question is, is this formula correct for AI? Yes or no? Go ahead. Yeah, question, do you believe that in this more general situation, this general formula for the AIs may still be correct, or whether this time they're going to fail? Yeah, I'm waiting. 30 of you are not responding, so I'm waiting. I love this feature. But the only problem is that I know you see the answers, so you tend to be influenced by those who say the majority. But remember that minority sometimes wins in my case. So if you want to switch to minority, you can still do it, I think. Okay, 17 don't want to. You don't see answers? I thought this morning they told me that they can see the. No, you don't. Nobody can see the result. Oh, somebody says I do. Or maybe because maybe because some of you are moderators and some of you are only participants. Maybe all the moderators, they can see the answers. All right. So yes, so result for only a second. So currently 19 say yes and 11 say no. 19 yes and 11 no. Some people say that you need to click on view poll. All right. Anyway, I give the answer. Oh, actually 20. Okay. Okay. The answer is actually yes, it works. So the majority wins here. Show response. Do you see the response now? Because I clicked on the response. Yes, yes. So it's on my side. All right, so this is good. I will show a response only when everybody has answered so that you don't get influenced. All right. So let's continue. B naught. Answer the question for B naught. Does it work or not? All right, so I don't show the response on purpose. I just tell you that 34 have not answered. 30 are still to answer. 27 still have to answer. 26. 22. 21 still have to answer. 20 still have to answer. 16. 15. All right. Okay, let's show a response. All right, so the answer is yes. Right. All right. So next. Force A naught vote for A naught. Yeah, somebody said it was, but just vote, just vote. So I'm not telling you. It's a good idea not to show you the response. That is good because you're not biased. You're not biased. Yeah, I can see that still 22 to 21 to respond. 7, 16. 15 to respond. 15 left. Hey, 15. 14. 13. 12. Okay, I give you the response. I show the response. All right, so it's kind of balanced. All right. Now, those who say no, you tell me why you don't agree with that. Can you somebody tell me why you think it fails? Why so many of you say no? You cannot explain. I'm going to make you jealous. The guy this morning give me the explanation right away. All right, I want to hit your pride. Show me that the second class is better than first class. No. Okay. So indeed, it doesn't work. The reason is as follows. Khalid? Okay, somebody said G of Z equals 0. No. Yes, Khalid?
Yeah, we need
Yeah,
to
Khalid,
use the going backward formula.
you need to use the
The
yeah, but
backward
that
formula.
doesn't explain. But it doesn't explain why it doesn't work. You see, I want to see an explanation that tells why this is not going to work. Look, why is this one working and not this one? This one, when you multiply G of Z by this, so this gets cancelled. You get B naught alone, and when you replace Z by lambda naught, all of the other guys are going to be cancelled. What about this one? When you multiply G of Z by this gets cancelled. A naught is alone. However, what happens to this one? Does it get cancelled? No. You're going to have a power of 1 here. And when you replace Z by naught here, what happens to this? This blows up. This blows up, not 0. This blows up. So this doesn't work. So what do we do in this case? So there's an easy way to get by, to find first B naught A3 AN, then find A naught by going backward. With A naught as only a known. And you find it. So you understand why this is called semi-educated? So what do you think is the next method? Of course, method for fully educated people. And normally I would hear laughters at that moment. All right, so which type of people am I? Am I non-educated, semi-educated, or fully educated? What do you think? Nobody says. Which one am I? Fully. Turn your volume up. You don't hear me very well. I don't know where I adjust the volume. All right. The answer is no, I'm not fully educated. I'm only semi-educated. So what do I mean by this? There is a formula to obtain a knot directly. In fact, I think Khalid, this is the method you were mentioning, right? Khalid, this is what you were saying.
Yeah, that's right.
Did you say that there's a name for this formula?
Backward formula?
No, the formula to obtain a knot. Is there a name? I think you mentioned the name for this formula. Oh no, you didn't. All right. So no. Okay. So there's a formula to obtain a knot directly, but use it at your own risk and peril. Okay, so I'm going to put the laughters myself. Yeah, so I don't know this formula. There is one. Yes, okay. I can hear you. Okay. All right. So myself, I don't know this formula, but there is one. So why I'm saying this is at your own risk and peril is because whenever I see a student trying to use this formula, he uses or she uses it from Laplace transform, which uses derivative. But remember, here we have z. Z is not a number, it's smiley face. What is the derivative of a smiley face? It's angry face. Haha. Here, there's no such thing, so yes. So for now, it's funny, but at the exam, it's less funny. Haha. There is a formula from Z transform, which is more, I think it is based on taking a limit to Z going to plus infinity or something like that. But so I just warn you this, okay? Method for fully educated people. Anyway, we have some method to obtain these coefficients, and how do we go in the time domain? So in the time domain, we know that once you have this expression, G of n is a naught. Okay, I'm going to avoid putting parentheses. Plus b naught. So now this one, you know what is the inverse Z transform of this? N plus 1, lambda naught to the power n, U of n, plus A3 lambda 3 to the power n, U of n, plus AN lambda n to the power n, U of n. And you are done with case 2. All right, so now there are many more cases. For example, you could have two pairs of double poles. For example, you could have sorry, it's skipping. Yeah, you could have lambda 1 equals lambda 2, and then lambda 3 equals lambda 4, etc. Oh, I don't need to cover this. If lambda 3 equals lambda 4, you're going to get another pair of terms like that here, and so forth. And all these formulas are going to work. But maybe there's an interesting case that mentioned is the scary case where you have triple pole. And the other ones are distinct. It's not difficult to figure out that in this case, you're going to get simply just another term which will correspond to the third power. But the issue is, so you are going to have also similar formulas for A0, B0, C0. But the question is, we don't know what is the inversely transform of the cube. We don't know that. What we know is that when it's we know the when there's a single power, you just have lambda to the power n u of n. When there's a second power, you get n plus 1 alpha n to u of n. But just for fun, could you guess what is here? Just for fun, can somebody propose answers? Khalid, yes.
I think it's gonna be n plus 1 times n plus 1, n plus 2 times n plus 1 times alpha power n ue.
Hey, you have the book in front of you.
No, I don't have.
Yes?
I don't have. Just I see the first one and the second one, and then they see if we have 4, it's gonna be n plus 3 times n plus 2, n plus 1.
I think you have seen that formula before.
Yeah, I see. Yeah.
Yeah.
I see.
Okay. It's not fun because I wanted to play with you because this morning I got all sorts of answers like n plus 1 squared or n plus 2. And all right, so okay, you gave the answer. All right, so it's less fun, but it's okay.
Transform into 5, linear 1.
What?
We did that in last form, 205.
But 205, I don't think they have a formula like that. I think it's different because in Laplace transform gives different formulas. I doubt it's like that in 205. I think in 205 it would be more like n squared. All right, so now I have a piece of news. This case will not be given at exams. Question. Is this good news? All right, so some 5 of you said no, it's not good news. Why is that? What? Isn't that good news? All right, I know that those who said no, given formula, there's no good news. The other cases are far harder. Yeah, that's true. In a certain sense, this formula is already given, so there's nothing to calculate, right? Now, it is true that you're going to have additional difficulties to find out and A naught, all right? I mean, these coefficients are easy to obtain. This is, I'm sorry, you don't see my cursor. This is ready-made, but all right, I think you know me now. All right, let's continue. Yeah, basically, I have covered all possible cases, but the bottom line is that you should not forget that g of z has a numerator. All right. So we are ready to move on to super case 2. Super case 2, n larger or equal to n. Now, let me tell you, immediately there's a mistake that students make. You know, at exams, I tell you, sometimes I tell you in advance what I give at exams. I like, at exams, I like to give the case m equals n. That falls into super case 2, not super case 1. That's a typical mistake. More, let's say, sometimes 1/3 of the class, when I give m equals n, they just solve it like as if it was super case 1. Now, super case 2, do you know what you need to do in this case? Can somebody tell me? Nobody? Abdullah, yes? Divide. But what's the purpose of dividing? What's the goal? Somebody said reduce the numerator to first order. No, wrong, wrong. To first order, you said? Okay, it's partially wrong. Okay, let's say. So somebody said, I forgot I didn't see the name. Reduce the degree of the numerator to order 1. That is incorrect, but it's no, not degree 1. Reduce to case 1. No, yeah, no, but how? Okay. Reduce the degree of the numerator, that's true, but not to degree 1. To what degree? No. Not degree 2, it depends. It's to degree less than Hanan, yes. Maybe it's too late, I already give the answer. It's to degree less than n. All right, let me ask you, when you divide something by 10, an integer by 10, what do you expect the remainder to satisfy? Yes, Shahana, yes. Up to 9, right. So that's the same thing here. So the goal is to reduce the degree of the numerator until less than n. Less than n meaning less or equal to n minus 1. All right, so long division. You need to do a long division. Now, you know what is embarrassing? The embarrassing part is that I don't know how to teach that part because I don't know how to do the long division. Okay, so I imagine laughters. No? No laughter? Okay. All right, so I'm going to explain to you and you will understand what I mean by this. I don't know how to do the long division in this country. So I'm going to show you how I do it in my country, and then you will understand what I mean by this. So I write this is b of z divided by a of z, where b of z is the numerator, and a of z is the denominator. All right, so how do we do that in my country? And I know that at least one student in this class is going to follow me. And so I divide b of z by a of z, like that. And I'm sure many of you are going to say, oh, what's that? What is he doing? I don't understand what he's doing, right? Q of z is the quotient, R of z is the remainder. All right, now, if I teach this way, I will get fired by my department because we're in the US. I have to teach it the way it is taught in the US. So I always remember that it has to be upside down. So you're going to say, no, my way. You're going to say, your way is upside down. And this way is the right way. Right? You're going to say that. Is that right? Okay. So I'm sure some of you, most of you are going to recognize this way, but some of you are going to recognize my way. Kindergarten way is which one? All right. So let me ask you a question. No, I'm sorry. So yeah, that's interesting. Somebody said the US is the only way that does it this way. I'm sorry to disappoint you that this is not true. It's actually at least every Anglo-Saxon country does it this way, and some part of the world have followed the British. In CS class? All right. So I just want to have an idea of who does it, the division, who does it my way. So if not, you say no, and if yes, you say. So here there's nothing confidential. You can see. All right, that's it. That's it. All right, so 5 people do it my way. I would tend to say who does it what way, but any attempt to say that is going to be politically incorrect. All right, but definitely The Anglo-Saxon countries do it the American way, and definitely every Latin country does it the other way. That is a safe answer, but not everybody is Anglo-Saxon or Latin, so the other ones, it depends. Scandinavian, maybe they even have another way. I'm tempted to say that the following: in Europe, only the British do it this way, and the whole continent does it the other way. But that is not even clear. Who cares? That I agree. Yeah. Yes, that's right. I just want to have some recreation and some fun. All right. So the difficulty is what comes later, because there's a big difficulty. So regardless of whether you do it the Latin way or Anglo-Saxon way, sorry for the names, is that polynomials must be written in reversed order. So I'm going to use the Anglo-Saxon way. When you do that division, you must write in this order. B n z to the minus n plus b1 z to the minus 1 plus b naught and so you must put in the order of the negative powers. The z to the minus n, you have to put the most negative degrees here first. And then the quotient and the remainder are going to be obtained in this way. So in the quotient here, you're going to get, so somebody tells me what power I'm going to have here. No, no, not minus n. N divided by n, wrong. 0, wrong. Tanan, 1, wrong. Positive n, wrong. N minus 1, wrong. The second, Khalid, again, correct. Khalid, you know everything. All right, so q n minus n. And then q1 z to the minus 1 plus q naught. All right, oops. Now the remainder. All right, here, what in the remainder, what power will you expect to get? Okay, I'm waiting for answers. No, not n plus n, minus n minus 1, right? Correct. Yeah, okay. Khalid, you are so good that at some point I will block your answers. You know, this my class is when it's such that when somebody is too good, I prefer to block his answers. So I said to you, my class is the only class where shut up is a compliment. All right. So this is it. However, when you go back to when you go back to the result of the division, you know that G of Z must be Q of Z plus R of Z divided by A of Z. That is the result of the division. Again, regardless of the method you have used, but regardless, you must change the order of the polynomials. But then when you go back to the expression, you have, so this is the dangerous part, you have to reverse the order of the polynomials. And then so this is Q of Z, and this is, I will call this G1 of Z. Q of Z, G1 of Z. So this is Q of Z, and then G of Z. So if you take the inverse Z transform of this, G of N equals Q of N plus G1 of N. So how do you get Q of N and G1 of N? But G1 of N you see the degree here is less than this one, so you use super case 1. All right, so G1 of N, you obtain it with super case 1. And Q of N, but we know, Q of N, you know what it is, because when Q of Z is like that, then you know that Q of N is this sequence. Q0, Q1, Qn minus N. All right, so you get Q of N, so you get G of N. All right, so if I give you a rational fraction G of Z, and I want to give you headaches at the second midterm exam, then I will make M larger than N, so that you are forced to go through this long division and this decomposition, and then you will be forced to find G1 of N going through the super case 1. And in super case 1, if I want to be nasty with you, I would put a mixture of complex numbers and double poles and all this. So that is what I would call pizza with everything on it. Do you like pizza with everything on it? No, you don't like pizza with everything on it. Is that right? So whenever you order pizza, they say everything on it, you say no? Okay. You are scared, right? Let me tell you, I don't need to give you a complicated formula for you to make mistakes. Even with simple numbers, which I will give, well, I will make sure I will give you super simple numbers. You will still make a lot of mistakes. I can tell you in advance. All right, so I don't have to make pizza with everything on it. I can just put pizza with just one flavor on it, and that is enough to make you give you headaches. Artichoke. All right, artichoke pizza. I will make artichoke pizza. Okay. Yes, I know that. I have a final polling question. I have a polling question. So wait, I'm typing the question. Answer. You say yes or no. You don't see the question? Yeah, you see. You can't vote when the result are displayed. So I stop the result then. It's working now. Oh, I see. Yeah, I see. So vote, please vote. I think because some of you are moderators and some of you are participants. So I don't show the result. Okay, go ahead. 15 are 13. 12. Okay, 12 have not answered. So that means if you don't answer, that means you don't really, you're in between. So, okay, so if you're in between, you don't answer. Okay, 10 are still replying. 9 have not replied. So, okay, I'm showing the response. Yeah, there's a vast majority who prefer chapter 1. But I'm going to tell you that somehow statistically, students do better at the chapter 2 at the exams. They get better results. And I'm sure you have heard that from the previous students. All right, so time is over. This is the end of the lecture. You have a question, Gregory. Okay, ask it. Gregory, you had a question, so I give you first. I don't hear you. Okay. The second had a question. There was a second person. Go ahead. Just ask the question. Somehow I don't hear. All right. So midterm 1 is chapter 1. Midterm 1 is chapter 1.
Can you hear me?
Yes.
Can you explain why G of Z blows up for B naught?
Oh, I see. You want to get back to the B naught case. All right. Let's go back to the B naught case. B naught case. All right. So when you multiply, okay, let's go back to this expression. So the B naught it works. It's when you calculate A naught that is a problem, because when you multiply G of Z by this gets eliminated, which is good. But what about this one? You multiply G of Z by the first power of this. So this one is not eliminated. It gets the power of 1 here. When you replace Z by lambda naught, you are going to get 1 here. So you get 0 here. So this blows up.
Okay, that makes sense. Thank you.
Okay, good. Any more questions? For the midterm exam is the first time I'm going to give you. I will give multiple choice exam. I've never done in my whole career, but I will give you more. I will give you more details when it comes. For now, you have to review. No matter how the exam is, you have to review your material. More questions? You're welcome. You're welcome. So if there's no more question, I'm going to stop the video. Thank you. No, I cannot give you some exam because I've never given such exam. The only thing that I may do is put a dummy exam, which is about has nothing to do with 306, just for you to see the format of the electronic format of the exam, for you to see how it looks like. But it's just a dummy exam with funny question. I saw an answer, but if you want to speak, that may be better. So Shahana has raised a hand. Jamel, you want to say something? Okay, I'm going to stop the video now. Okay, there's a very slow response.